Okay, guys, before I show you the examples that Miss Yelverton had on the worksheet, I've got a couple of real simple ones myself that I want to show you. I want to give you two ways to solve these equations. I'm going to start with this equation right here, and I need you to notice that there are fractions in it. So you have to remember your fraction rules. For example, to add fractions together, you have to find a common denominator. That rule's going to come up a lot. All right, I'm going to show you two ways to solve this equation. One is a long way that I don't think you should use all the time. I'm going to do it in this one example, but I'm going to show you a shorter way second. All right, the sort of longer way is to look at this side of the equation and see that I have two fractions that are added together, and so I need to add them together. All right, I see I have a 6 and a 2 as my denominators. The common denominator for 6 and 2 is going to be 6. So I need to write these equations as something over 6. Something over 6 equals 2/3. 6 being the common denominator for those two fractions. All right, the first fraction already has a 6. Don't have to do anything. Second fraction has a 1/2 in it. To find my common denominator, to move from 2 to 6, I have to multiply by 3 on the top and the bottom. That way I can add these two fractions together. I now have x plus 3 over 6 is equal to 2/3. And when you have a fraction equal to another fraction, the technique I like is cross multiplying. So I can multiply those crossways. I'm going to get 3 times x plus 3 equals 6 times 2. Now I distribute the 3 in. This becomes 3x plus 9 equals 12. And now I just use, my Math 1 algebra to solve it. Subtract 9 from both sides. I'll have 3x equals 3. So that tells me that x equals 1. And that is my candidate solution. I think that will work. All right, that's one way to solve it. A second way to solve it is, instead of looking at the just one side of the equation, 6 and 2. Instead of looking at one side of the equation, I want to look at the entire equation and then find a common denominator for all of the fractions I see. In this case, it happens to be the same number. The common denominator for 6 and 2 and 3 is still 6. But I want to multiply the entire equation by 6. So I'm going to multiply 6 times x over 6. I'm going to multiply 6 times a half. I'm going to multiply 6 times 2/3. All right? I'm multiplying 6 by everything in the equation. Do notice that the original equation is still here, right? I've still got x over 6 plus 1/2 equals 2/3. I just multiplied everything by 6. All right. When I do carry out my multiplications, this 6 and that 6 will cancel. And I'll be left with an x. Over here, that 6 and that 2 will cancel. I'll be left with a 3. 3 times 1 is 3. Over here, I will cancel my 3 and my 6. I'll be left with a 2. And 2 times 2 is 4. If I now solve this equation, subtract 3 from both sides, I get x equals 1. Same answer, but notice how many fewer steps there were in solving this equation. In the blue solution method, the long way, I found a common denominator, then cross-multiplied, then had lots of algebra to do. In the green way, the second way, I cleared the fractions in the very first step. Notice that my very first step here, all the fractions are gone. All right, and that's the method I'm going to use when I start doing the examples on Ms. Yelverton's worksheet. I'm going to try and clear the fractions in the first step. But the thing I needed to find in order to do that is the common denominator for every fraction in the equation. Let's look down here at my second example. It's a second equation. It's a little bit like the first one, but let's say it doesn't come to you what the common denominator for 4, 6, and 9 is. Well, the way I approach it is I factor all of the denominators and look at what factors appear. I don't know if you remember doing little trees like this. 4 is the same thing as 2 times 2. 6 is the same thing as 3 times 2. And 9 is the same thing as 3 times 3. So I'm able to factor all the denominators. Let me write the equation again using those factors. X over 4. 4 is the same thing as 2 squared. 1 over 6. So 6 is 3 times 2. And then 2 over 9. 2 over 9. 3 squared. All right, so this is the same equation. I've just written the denominator in factored form. Now, why do I care about that? Well, I can now see that my magic common denominator that's going to clear my fractions needs to have a 2 in it, and it needs to have a 3 in it, because I see 2's and 3's in the denominator. I also need to make sure that I use the largest power of each factor that I see. So the largest factor of 2 I see is 2 to the second power. The largest factor of 3 I see is 2 to the second power. So my magic common denominator is going to be 2 squared times 3 squared. In other words, I just look at the largest power of each factor and make sure that that's represented in my largest common denominator. 2 squared, this is the same thing as 2 squared is 4, 3 squared is 9, 4 times 9 is 36. So 36 is the magic big common denominator that will clear the fractions if I use it. And let's go ahead and solve this equation using that common denominator. I'm going to multiply everything I see by 36. So 36 times x over 4 plus 36 times 1 over 6 equals 36 times 2/9. My original equation is still there. I've just multiplied it by 36 on both sides. Okay, if I now start canceling things, the 36 and the 4 will cancel, and I'm left with a 9. And 9 times x is 9x. The 36 and the 6 cancel, and I'm left with a 6. And 6 times 1 is 6. The 36 and the 9 will cancel, and I'm left with 4. And 4 times 2 is 8. So using this magic common denominator that I found, I was able to clear the fractions in the very first step, and now I've got really what I consider a pretty easy problem to solve, right? Subtract 6 from both sides, I get 9x equals 8 minus 6 is 2, which tells me that x is equal to 2/9. Hope my math is done right. The step that I want you to remember is that when I can't see a common denominator instantly, I factored all of the denominators, and I picked my magic large common denominator uses all the factors that I've found here. All right, so I see that I have 2's and 3's. The largest power of 2 is 2 squared. The largest power of 3 is 3 squared. That will give me my magic common denominator. All right, now I showed you that with numbers because when we do this with letters, you're really going to have to do your factoring to find your common denominators. So let's move over to the actual worksheet. I'm not going to do all of these for you, but I do have all of them answered in a PDF file that I'll be happy to send to everybody. All right, let's look at this very first problem here. I see that I have fractions all through it, and I don't like fractions. So I've got to find a common denominator that I can multiply everything by so that the fractions disappear. Okay, there's no factoring of the denominators I can do. I see that I've got an x in both of those spots. I've also got a 3. I've also got a 5. So my common denominator needs to have all of those things in it. It needs a 3, and it needs a 5, and it needs an x. Right? That represents the largest power of every factor I see. So 15x is going to be my magic multiplier, my common denominator for the equation. And if I multiply everything times 15x, all the fractions should disappear. Let's try it. 15x times 4 over x minus 15x times 7 over 3x equals 15x times 2/5. All right, let's start canceling things. In the very first term of the equation, I see the x's cancel, and I'm left with 15 times 4, which is 60. In the second fraction, the x's cancel. The 3 will cancel with the 15 and leave me with a 5. So that gives me 5 times 7 is 35 for that term. Finally, over here, the 5 and the 15 cancel. I'm left with a 3. So on the right side of the equal mark, I've got 3 times x times 2, which is 6x. 60 minus 35 is 25. And so x equals 25/6 is my candidate answer. That is to say, when you're doing your algebra, they don't tell you this in Math 1 and 2, but it's a little secret that mathematicians want you to know. All this algebra does is give you a set of numbers that you can try. These will be the solutions in the things that you find when you solve your equation. It does not guarantee that they are solutions. It just says that if there are solutions, you have found them by doing the algebra. So this 25/6, what I should technically do is plug that back into the original equation and see that it works. But I'm not going to take time to do that. On my answer sheet that I have for you, I do that. I've plugged the 25/6 in, and it works. All right, let's move over to this next equation, because I think it really illustrates well how you need to do factoring to find the magic denominator I'm going to multiply by. All right, I don't think I can factor anything in that first denominator, and I don't think I can factor anything in that second denominator, but I do think I can factor this third denominator, this 6x squared plus x minus 2. I've sort of done the factoring ahead of time. I know that this, I know you guys use like an x, I don't know this method for factoring a binomial, to factor a trinomial into two binomials. I don't know how that works. I only learned to do it the hard way. I need two things that multiply together to give me 6x squared. That's going to be 3x and 2x. Now I need to use the factors of -2 in these second slots so that if I were to FOIL these two together, I would wind up with +1 in the middle. Well, the factors of -2, there really are only a couple of choices. I'm going to say I put a +2 there and a -1 there. Now, how do I know that that's the right answer? Well, if I multiplied this out, I would get, you remember FOIL? This is just me checking that my factoring is right. If I multiply the first terms together, that gives me 6x squared. The outer terms give me -3x. The inner terms give me +4x. So -3x plus 4 gives me +1. And finally, 2 times -1 gives me -2. All right, so that was just me checking that I did the right thing with my factoring. Oh gosh, Creighton, get yourself together. 3x plus 2 and 2x minus 1. It's not an accident that those numbers are showing up over here. I mean, that was kind of a clue for me of what the factoring needed to be. All right, that whole point is to say that I've got a factor of 2x minus 1. I've got a factor of 3x plus 2. And the same things show up over here. So the magic common denominator that I need is something that uses all of the factors that I see. In this case, that is going to be 3x plus 2 times 2x minus 1. And I'm going to multiply that by every fraction that I see. I'm going to multiply that times, I might not be leaving myself enough room. Let me write it again so that I have enough room. 3x plus 2 times 2x plus 1 times 5 over 2x minus 1 minus the same thing, the same magic denominator, 3x plus 2 times 2x plus 1 times 7 over 3x plus 2. And that has to equal, same thing, 3x plus 2 times 2x minus 1 times 9 over 3x plus 2 times 2x plus 1. So all I've done, I say all, I want you to notice that the original equation is still here, right? There's the parts that are the original equation. I factored the bottom of that last fraction so that I could find a magic number that would eliminate my fractions. And now I think my fractions will go away. Let's see, in my first fraction, I see that I have a 2x plus 1. Oh, is that 2x minus 1? Crap. 2x minus 1. Sometimes I don't have the cent guy. But go. Okay, there we go. My 2x minus 1s will cancel here and here. And I'm left with 5 times 3x plus 2. Over here, my 3x plus 2's cancel. I'm left with 7 times 2x minus 1. And over here, everything cancels. And I'm simply left with 9. Why is that better? Well, instead of having all of this, complicated fractions up here to deal with, I have changed it into a relatively simple algebra problem by multiplying through by the common denominator. Now it's just baby algebra, right? I have to multiply the 5 in. 15x plus 10 minus 14x plus 7 equals 9. That's me just multiplying things in. 15x minus 14x is 1x. 10 plus 7 is 17. Still have the 9, so that tells me that x equals 8. That is the solution that I should now plug back into the original equation. Again, I'm not going to do it because I don't have room and because I want to give you as many of these as I can. Let's look at this one listed D right here. I'm going to do the same process. I see fractions. I hate fractions. Let's get rid of fractions. I notice that I have something I can factor here. X squared minus 9 can be factored. So I'm going to rewrite that fraction. Let me get back to where I can write this problem again. I'm going to just rewrite the problem. But I'm going to factor that bottom over here. X squared minus 9 is a difference of squares. You should know that it can be factored as x minus 3 times x plus 3. Okay, I need the magic denominator that I can multiply each fraction by so that all the fractions go away. I see that I have a factor of x plus 3. I have a factor of x minus 3. But I don't have anything extra over here. So my magic denominator is going to be what I construct using every factor that I see. I see that I have an x minus 3 and an x plus 3. So that is my magic common denominator. X minus 3 times x plus 3. I'm going to multiply by everything I see. 1 over x plus 3 equals x minus 3 times x plus 3 over 7 x minus 3 minus x minus 3 times x plus 3 times 2 over x minus 3 x plus 3. It looks complicated right now, but we're making it complicated so that it becomes easy in a minute, right? Our original equation is still here, but I'm multiplying through by a magic denominator here, right? Okay, and things should cancel out pretty quickly once I do this magic denominator. I'm going to cross out those x plus 3's. They cancel. I am left with an x minus 3 equals, over here the x minus 3's cancel. I'm left with 7 times x plus 3. And in the last term, both the x minus 3's and the x plus 3's cancel. I'm left with 2. So by multiplying by the magic denominator, all the fractions go away. I'm going to multiply my 7 into this side and get 7x plus 21. 21 minus 2 is 19, I guess. So what am I going to do now? I'm going to subtract x from both sides, and I'm going to subtract 19 from both sides, and I'm going to get minus 22 equals 6x. Yep. So that tells me, if I move over here, that x is equal to 22 over 6, which is the same thing as 11 over 3. And that is my answer, which I ought to plug in and check, but am not going to. Okay, I'm going to stop with the I'm not going to check it. I'm going to really start checking from now on. Let's look at this next problem. Here I've got an equation. I'm looking at 2a right here. I've got an equation with fractions, and I hate fractions. So what is my common denominator for the equation? Knowing that that's the same thing as 3 over 1, what is the common denominator that I see when I look at all three fractions together? Here I have an x plus 4, there I have an x plus 4. And that's really it. This is 1 right there, but that doesn't really matter. So it looks like x plus 4 is my magic denominator. So I'm going to write x plus 4 and multiply it by everything I see. X over x plus 4 equals x plus 4 times 3 minus x plus 4 times 4 over x plus 4. Once again, I've got my original equation is still here. That equals 3 minus that. I've just multiplied everything by x plus 4, hoping that things will cancel. Well, not hoping, knowing that things will cancel. X plus 4's cancel here, and I'm left with an x. I can multiply this 3 in, I suppose, and get 3x plus 12. Over here, the x plus 4's cancel, and I'm left with a 4. By the way, when you get a certain bit of facility with these, I don't always write this step out. I sort of do this in my head. I know that the x plus 4 will cancel, so I don't always write out the full step of what I'm multiplying. However, in the answers that I made for this worksheet, I always wrote out every possible step. All right. I need to get back and make that a 4. Now, this is simple stuff to solve, right? X equals 3x. Plus 12 minus 4 is plus 8. I can move this 3x to the other side. I'll have negative 2x equals 8. So x equals 8 over negative 2, which is negative 4. Now, I should be doing this the whole time. I'm supposed to verify if that answer is a true solution. Right now, it is a candidate solution, meaning if the solution's there, this is going to be it, but I have to go back and check it. So now I'm going to look back at the original equation here, and I'm going to plug in negative 4 everywhere I see an x. All right? So if I plug in negative 4 everywhere I see an x, equals 3 minus 4 over x plus 4. All I did was write negative 4. I didn't do it, did I? That's supposed to be a negative 4. there. Now, what I did was I wrote in a -4 everywhere I saw an x. I hope you can notice now that, oh, come on, Creighton, get yourself together. I hope you can notice now that this denominator is a problem. That denominator is a problem. -4 plus 4 is 0, so I've got -4 over 0 equals 3 minus 4 over 0. Those dividing by zeros are no good. So although our algebra showed us that we had -4 as a candidate solution, if there's a solution to this, we have found it in this little box. But that candidate solution is not a solution of the equation. It is what we call an extraneous solution. So the true answer, the solution to this problem, is that there are no solutions. We found one candidate, but it does not work. Is there another good one I can show you? This is your homework down here, and I went ahead and worked out all of the homework problems. When I handed this sheet out, everybody looked at problem number 9 and was like, wow, look at problem number 9, how impossible. Well, let me just get you started on number 9. Again, I've written out complete solutions to this. So let's start on this problem number 9. What is going to be the common denominator that I can multiply everything through so that I get rid of these fractions in one step? Well, the key thing you need to realize is that k squared plus 6k can be factored. K squared plus 6k is the same thing as k times k plus 6. All right, in other words, I sort of factored out a k from both sides. So I can, rewrite this equation. You won't have to rewrite things every time, but I'm doing it now just because I'm bored. This is k times k plus 6. That's the factored form of that first equation. K minus 2 over, again, I factor the bottom, k times k plus 6. And I get, and still, there's nothing to factor here. Okay, so what are the factors that I need to take into consideration? Well, I have a k, and I have a k plus 6. K plus 6, k, and k here. So the common denominator, I need to use every factor that I see. So it looks like my magic denominator is going to be k times k plus 6. So to solve this equation, I need to multiply everything that I see times k times k plus 6. And you should, every time you do a multiplication here, you're going to see things cancel, right? In the first fraction, everything's going to cancel out, both the k and the k plus 6. Second fraction, everything's going to cancel. In the third fraction, the k will cancel, but the k plus 6 remains. I'm not going to write all that out for you, but that's what I'm getting at. Let's look at number 12 and just get started on it. What's the magic common denominator? 1 can be written as 1 over 1. So what factors do I see? I see a 1, and I see an x, and I see an x plus 4. So the magic denominator is x times x plus 4 times 1. Don't have to write down the multiplying by 1. Okay, if I multiply everything in that equation times x plus 4, what happens? Multiplying this thing into all of them. Well, x times x plus 4 times 1 is x times x plus 4. X times x plus 4 times 1 over x. The x will cancel, and I'm left with x plus 4. And in the final fraction, the x plus 4's cancel, and I'm left with just an x. And that is the thing I need to solve. It's a lot simpler than with the fractions. All right, I'm going to stop there. I hope you got my point. These are the solutions that I made for you. I've written out the method that you need to use. Find the magic denominator, multiply every term by that denominator, and then solve what's left. There shouldn't be any fractions left. Finally, you should check each candidate solution in the original equation. Now, when I wrote that out down below, I want you to see, like in this first equation that we solved, 25 over 6 was the answer that we got. I don't know if you remember that. I'm not going to show it to you. You can see here where I plugged it in. Here I plugged it into what I'm calling the left-hand side. And the right-hand side was just 2/5. So you can see where I plugged it in right there. That's the left-hand side. That's the right-hand side. And you can see that they're both equal to 2/5 when I work it out. In the second problem, where we got -8, remember that being the solution, here you can see me plugging it in. I'm plugging that -8 in everywhere I see an X. I do a little bit of arithmetic, and I see that the left-hand side is that. Plug in a -8, do a little arithmetic, the right-hand side is that, and those match. So you've got solutions to every problem written out like that. I hope that that helps you. I will put a link to this worksheet on the description of the YouTube channel, and maybe I'll put a QR code if I feel like it. Hope that helps everybody. Bye.